Yes is zero, then our is equal to inverse is one, then our is negative. This is what our into 2 raised to.
So next one, we also encounter a few of the other data types, that is integer, real, and time register data types. So we'll look into what are these things and how it can be defined, what can be how those have to be dealt, because we have to consider these things. Because whenever you are connecting a hardware, what happens is I might be having a value in the range of 0 to 5 volt, but how that 5 volt will be reflected? I can have a voltage specified as say 4.52. So how this real number will be reflected in this thing, and I have a timing specified. So how I can go ahead with these kind of informations. So first one, let us discuss regarding integer. These are basically general purpose register data type. In this case, they are basically used in quantities wherein we can go for counters and indexes. So in previous case, we saw that we were accessing say something as bus of 7. So this is the integer value. In such kind of cases, we might require it. So here I am directly specifying the number, directly specifying the number. Instead of doing this, what I can do is I can define a variable as say index, and I can assign a number to that, and then I can go ahead bus index. So something in this form. So that is what it specifies. Just give me a second. So next one is the integer data type what we were discussing. So in this one, this is a general purpose register data type, which are basically used for manipulating quantities such as which we use in counters, indexes. So these kind of things we go in for integer data type. So how do I declare a integer data type in Verilog? The keyword itself is integer. I make use of the keyword which is integer. Now, what is the default size of the integer? It is again dependent on the machine or the simulation simulation software what is present, because a few of the systems might support 32 bits, few of the systems might support 64 bits. So depending on this, it might change around. But by default, what they specify is minimum the integer consumes 32 bit of memory. It consumes 32 bits. So that is what we have. So the default size again dependent on the host word size, but at least it is 32 bits what they mention. So it again depends on the host. It might be even 16 bits also might be there, but suggested is at least 32 bits. Now in integers also we encounter few things. That is we encounter say positive numbers, we encounter negative numbers. So how we specify, if the numbers are only positive, we specify it as signed quantity. If it is negative, if it is having both, if it is having only positive numbers, it is unsigned. If it is having both, it is signed integer. So we have two things, signed and unsigned integers. So that is the example what we have. The register values or register data types can store unsigned integers. So here we have for unsigned integers, we can go ahead with these kind of register data types. In integer, what happens is so here what the specification is, reg data type supports only unsigned numbers. It is basically stores the unsigned numbers. But integers, what happens is they store the signed numbers. So that is the thing what we have to check out for. So if I go for counter, for example, counter, or if I go for even index also. So counter, if I keep on decrementing, say counter goes to 0. If it decrements, what happens is it goes to -1, -2, so on. So in such cases, what happens is the integer data type should support the signed quantities. So if it is not supporting the signed quantities, what would happen is these numbers would never be available. So if I decrement it, it would come back cyclically to the last highest number which is present. That is 2 raised to 32 minus 1. So it would be something in this form. So just an example is provided here. So we have a counter which is declared as integer. So this is a general, this can be utilized for any general purpose. Say you want to keep the track of how many how many elements are present. So you are taking it from the sensor, you are reading it. So you're doing for that purpose. You're so for that purpose you can utilize these kind of counters. Even in your software loop, even there also you can have it. Counter is here, if you just see, it is initialized to minus. So this is just to represent that integer is capable of handling negative numbers. So you can store a negative number. So imagine the same thing if you want to do using bit operations. That is, I'll tell that you define an integer of 32 bits, and then you go ahead. So it becomes tedious process. So instead of that, what I'll do is directly I'll refer to an integer and then initialize it, then utilize it where all it is required. Okay. So next one which we have is the real data type. So what is real? So if you have, you might have seen the values like say 4.24, 5.01 minus 5.10, something of this kind. So here we have the decimal part. Here we have the decimal part and we have the integer part. So when I have numbers in these forms, they will be falling under real data types. They will be falling under the real data types. And this representation is nothing but decimal notation what we specify. This is the decimal notation. Now the same thing I can have in different form. I can have in different form. Okay, next this thing is real data type. So real data type, what happens is we have seen we generally encounter number in a decimal notation forms. That is, for example, we encounter some values like 3.34 or minus 3.12. So we encounter such kind of numbers. So we have to deal with such kind of numbers also in your Verilog. So in order to do that, we have to go for real data types. So that is what we have to do. So here we how we can represent these numbers. This representation is called decimal notation. This is decimal notation. Now the same numbers I can represent it in different. That is, I can represent it as say 3 into, sorry, so it is 334. Say if I take this number, it's 334 into 10 raised to minus 2. So I can store it in this form, or else the same number I can store it as 0.334 into 10 raised to 10 raised to 2. Sorry, 10 raised to 1. I can store it as 10 raised to 1. So here what you have the mantissa part and you have the exponent part. You have the mantissa and the exponent. So we can specify this number as 334. This how it is specified is, it is specified as E and then whatever number is there. Similarly, this one we can go ahead with that form, but generally this is what is preferred. So what this is called as scientific notation. This is called scientific notation. So we have it in this slide. So real number, the keyword which we use to declare a real data type is real. So we can specify the it in two forms. One is decimal notation and one is scientific notation. Decimal notation is in this form, that is say 3.14, directly in this form. We have another one which is scientific notation. So which is specified in this form 3e6. So what does this imply? This is the mantissa part 3. This is the exponent part 3 into 10 raised to 6. So this is how we specify. Now here what happens is since we are just representing it over here, we don't have any general specification for the range. But if I have to go for range, right, then there are some conditions. That is mantissa provides me some information, exponent provides me some other information, dynamic range and precision. Such kind of things come in. So I'll not go into depth of those things. So by default, which value is stored over here? By default, real number stores 0. By default, real number stores 0. Real data type stores 0. So we cannot have a declaration for the default is equal to 0. Now, what happens if the real value is assigned to an integer? So this is a known fact to you all because in C programming you do this many a times. So in this one, what happens is, suppose if I take this real number and I assign it to integer int 1, I assign it to int 1. Then what would happen is if I'm writing it as 3.14, it would truncate, say, the decimal portion and just 3 over here. Or it depends on if it is suppose, so here if I just see it is 3.14, which is very close to 3. So 3 will be stored here. Now you might have a value like 3.99. So what happens is this value, if I just see it is very close to 4. So in such conditions, as per the discussion, what would happen is 4 would be stored here. So when I'm assigning a real value to an integer, the value gets the value stored in the integer would be the closest integer to that notation or to that real number, closest value to that real number. So that is what would happen. It would be rounded off and to the nearest integer. It depends on how it goes. Even in some cases, what would happen is we might see that only 3 is stored. This part is truncated. So this also is possible. So here, just remember, if this thing is happening, real number will be rounded off and then to the nearest integer which is present. So here we have an example. Real is the keyword, delta is the identifier. So you have declared a variable. So this is a variable what we have declared, which is of type real. Then here we can see that we have two assignments. What we have done, we have assigned delta is equal to 4e10. So it is 4 into 10 raised to 10. So which is in scientific notation form. And here what we have done, we have stored in decimal notation form, which is 2.13. Now here we have another specification, that is integer I. And in next this thing, what we are doing is we are storing the value of delta. And here you can see that the last value of delta is 2.13. So here what would happen? This part would be rounded off. This part would be going off and 2 would be stored in I. So this is what will happen in real data type. So next one we have time data type. So what happens in this case? Now, whenever we are doing a Verilog simulation, right? We have simulation time. With respect to simulation, we have the simulation time which will be shown on the screen. So how do I get into those things? So time register data types basically help to store simulation time which will be generated. what happens is in some of the slides you might have seen in the starting this thing. So we had some things wherein we had some signals which were present, some were so something in this form. So each is having its own timing. I want to store this timing, that is simulation information, that at this location, that is timing t1 of simulation, this is what had happened or something. I want to store the information, but I want to store the simulation time. So in order to store that, what I do is I go for register data types which are of type time. So this is basically related to a simulation. It is not the time with respect to the hardware. It is the simulation time what they are speaking. Then the keyword what we use to declare this one is again lowercase time, which is utilized for defining these type of data types. Now, what is the width of such kind of data types we are implementing? So here, at least again, but again, it can be dependent. It can be dependent how the simulation goes on the hardware with the system. Now, since we are speaking of time, right? Time is having a SI on it, so which is nothing but seconds. So unit of time, even in these things, will be S, which is referred to as simulation. Now, what happens is we have these things. Okay, just keep track of the hardware should be in sync. In that case, it must have to the developer development. So these are just a few things with respect to the data types of time. So here just an example: time save underscore simulation time. So what we are doing is we want to save the simulation time. So in order to save that, we make use of dollar sign and then the specified as time. That is a keyword, dollar keyword as time. So this will save the current simulation into this data type, into this data type. And if I have to do this, this one should be of the data type time. This one should be of data type time. So here I missed out, I guess. So that is hash time will be invoking the simulation time to be recorded. Okay. So this is the current simulation time what will be recorded over. Okay. So this is these are few data sets what we have discussed. Again, we have a few more to be discussed. That is arrays and memory and the parameters. And then lastly we will be coming to we'll discuss and with the next class and we'll wind up with this part. And later we'll be going ahead with now here for your information